Why do our smartest computer vision models struggle to keep up with live video? It is often because they waste precious computation predicting every single word, like the or is, instead of focusing on the actual meaning. The researchers behind VL-JEPA propose a solution that predicts meaning directly, bypassing the bottleneck of traditional language generation. The core problem is that traditional vision language models predict text token by token in data space. They obsess over surface details like word choice and style, which creates a massive computational bottleneck for real-time applications like robotics that need instant answers. To solve this, the authors propose shifting from token space to embedding space. While token space treats distinct sentences like the lamp is off and room is dark as totally different, embedding space maps them to nearby points because they share the same underlying semantic meaning. This concept leads to VL-JEPA, a joint embedding predictive architecture. Instead of reconstructing text word for word, the model learns to predict the abstract representation of the target, allowing it to focus strictly on meaning and ignore linguistic noise. Let's look under the hood at how this non-generative architecture actually functions. The framework uses 4 key components. An X encoder compresses video, a predictor maps visuals and queries to a target embedding, and a separate Y decoder is used only during inference to translate those abstract embeddings back into human-readable text. To train this, the researchers use InfoNCE loss to align predicted embeddings with target embeddings. They initialize the predictor with Llama 3.2 and the encoders with models like V-JEPA2 to jumpstart the system's reasoning and visual capabilities. So, does this shift to embedding prediction actually improve performance over standard large language models? This figure compares VL-JEPA against traditional token prediction models under strictly aligned settings. It demonstrates higher scores in captioning and classification while running significantly faster and using fewer trainable parameters. One major breakthrough here is selective decoding. Instead of processing every frame, the model monitors the embedding stream and only generates text when it detects a significant semantic shift, reducing decoding operations by nearly 3 times. While it established a new state-of-the-art on the World Prediction WM benchmark, even surpassing GPT-4.0, the authors note it is not yet a replacement for tasks requiring complex high-level reasoning or external tool use. To learn more, head to emergentmind.com.